Assalamualaikum and good morning everyone. My name is Nurul Ain and today me and my team will present our project titled Integrated Water Treatment and Wastewater Treatment Design for a Remote Orang Asli Community. Our project focuses on designing a sustainable water treatment plant and sewage treatment plant for a remote kampung Orang Asli consisting of approximately 100 houses with 500 residents. Currently, the community depends on untreated river water for their daily activity and they do not have a proper wastewater treatment system. Since the village is located in a remote forest area with limited electricity, conventional treatment technology are not suitable. Therefore, our design imposes a sustainable, simple and reliable treatment system that can be provide safe drinking water while protecting the surrounding environment. For the background of the study, the community relies entirely on river water for drinking, cooking and other domestic uses. The lack of electricity also limits the use of advanced treatment technology, making low energy and practical solutions more appropriate. The existing problems including poor water quality with high turbidity and harmful pathogens which increase the risk of waterborne diseases such as cholera, typhoid, dysentery, and diarrhea. In addition, the absence of a proper water collection and treatment system lead to the river pollution, affecting both public health and aquatic system.
Environmental impact show positive impact such as cleaner river water and improved public health. Although there are temporary negative impact like construction noise, dust, vegetation disturbance, sludge and odor which be managed properly. Several engineering challenges exist, including remote sites access, limited electricity supply, seasonal change in water quality, lack of technical skill, and budget limitation. However, this can be addressed through proper design and planning. For proposed improvements, including the use of solar energy, water investing, construct wetlands, community training, and sludge reuse, which enhance sustainability and support several sustainable development goals. Both systems comply with DOE, SPAN, Malaysia Standard, and WHO guidelines. In terms of sustainability, the project provides environmental benefit by reducing river pollution and protection ecosystem. Economically, it uses low-cost and energy-efficient methods such as gravity flow, while socially it improves community health and reduces waterborne disease. For water table, this table estimates water demand for a community of 100 houses with 500 people. Daily water use is 90 cubic meter per day, averaging 3.75 cubic meter per hour. During peak demand, it rises to 135 cubic meter per day and 9.375 cubic meter per hour. About 18 of the water use become wastewater equal to 72 cubic meter per day.
Assalamualaikum and good morning everyone. My name is Nurul Ain binti Muhammad Rashid. Today, I will explain about the water treatment process and water treatment design proposed for this project. Our main water source is river water, so the water needs to be treated before it's safe for the community. First, the river water enters the intake structure. Then, it goes through the screening process to remove large debris such as branch, leaves, and rubbish. Next is coagulation, where a coagulant such as alum is rapidly mixed with the water. After that, during flocculation, the water is mixed slowly so that the small particles can combine and form larger flocks. Then, the water enters the sedimentation tank where the heavy flocks settle at the bottom by the gravity. The water then passes through the refrigerant filter to remove the remaining suspended particles. After filtration, the water undergoes chlorination to kill harmful microorganisms. Finally, the treated water is stored in the clear water storage tank before being distributed to approximately 500 residents. For our water treatment design, we compare our selected design parameter with the typical design range. For example, the rapid mason detention time is 2 minutes, The flocculation detention time is 30 minutes and the chlorination contact time is 30 minutes. Based on our comparison, all selected design parameters are within the acceptable range. Therefore, the proposed water treatment design is simple, reliable, and suitable for a remote community with limited electricity and technical expertise. Thank you.
Today I will present our proposed sewage treatment plan or STP designed for the Kampung Orang Asli community. This STP is designed for a population of 500 people with an average wastewater flow of 72 cubic meters per day. The treatment system is simple, sustainable, and suitable for a remote area with limited electricity supply. First, raw wastewater, also known as influent, enters the treatment plant from the village collection sewage system. This wastewater contains suspended solid, organic matter, and various impurities. Next, the wastewater passes through the bar screen. The function of the bar screen is to remove large material such as plastic, leaf, rugs, sticks, and other debris. This protects the downstream treatment unit from clogging and damage. After screening, the wastewater enters the grid chamber. In this unit, heavy inorganic materials such as sand, gravel, and grit settle at the bottom due to gravity. Removing these materials help reduce wear and tear on the treatment system. The wastewater then flows into the primary clarifier in the circular tank. Suspended solids settle to the bottom and from sludge, while the clarified water outflow through the weir. Based on design calculations, the clarifier achieve approximately 60 to 78% suspended solids removal and 34 to 44% BOD removal. Finally, the treated water known as the influent or outflow is discharged safely into the environment or can be used for suitable purpose, depending on regulatory requirements. In conclusion, this STP design provides an effective low cost and environmental sustainable wastewater treatment solution for the Kampung Orang Asli community while requiring minimal operation and maintenance.
First, our design directly support SDG 6. The water treatment plant accommodate an average domestic demand of 90 meter cube per day for 500 residents. Meanwhile, the sewage treatment plant treat 72 meter cube per day of wastewater. This safely break and the chain of waterborne disease in the village. Second, this project strongly support SDG 14 by integrating physical treatment with the biological concentrate will wetland. Our system successfully remove 78% of suspended solid and 44% of BOD before river discharge. This prevent river eutrophication and protect local aquatic biodiversity. Move on, why is this engineered system highly practical for a remote Orang Asli village? From a cost perspective, we employed the natural topography by designing the PVC pipe network with a 0.05 gradient. As a result, water move into gravity flow, eliminating expensive power-heavy mechanical pump. From an operational perspective, the plant unit are static and simple. Daily maintenance, such as a cleaning bar screen and monitoring chlorine level, can be easily done by trained villagers without need a full-time engineer. In conclusion, this integrated WTP and STP design is highly practical, cost-effective, and eco-friendly engineering solution. It successfully achieved our main project, elevating public health with greatly preserving the surrounding environmental for the future. Thank you.
I just had to let you know you're